We might also be asked to find values like the area of a triangle or like the length of a side, okay? So we need to work out how to find the distances between 2 points. So if I was to sketch a graph and plot 2 points here, A and B, then it would be useful to find the distance between A and B, okay? And so what we're going to do is actually use Pythagoras. So if I was to draw a right angle triangle like here, like this, and I'm going to call B as coordinates x1, y1, and A as x2, y2. As you can see, if we were to do Pythagoras, it's the length squared and then square rooted, right? So if I call this D here, then this length will be x1, or sorry, y1 minus y2, and this length here will be x1 minus x2. So in fact, the general distance equation is just y1 minus y2 squared plus x1 minus x2 squared. So that's the distance between 2 points on a graph. It's just using Pythagoras. And so with this, we can find stuff like areas, as I said before, and different lengths between different points. Right, let's just try this question here. So we have the points R and S on the straight line L1, and work out the equation for the straight line L1. So this is what we've learned before, straight line equation. So we're given that R is 5, minus 2, and then S is 9, 0. So we find the gradient first. So change in y over change in x, so 0 minus 2 over 9 minus 5. We get 2 over 4, which is 1 over 2. So the gradient is 1 over 2 x plus c. Finding c, just plug in either value. So I'm going to plug in the s value. So we get 0 is equal to 9 over 2 plus c. So c is negative 9 over 2. So L1's equation will be y is equal to half x minus 9 over 2. Okay, so this first part is very simple if you look at the previous videos. Right, the straight line L2 is perpendicular to L1. So the L1 and L2 are perpendicular, meaning we know that the gradients, if we multiply them together, we should get minus 1. And passes through the point R. So R is here. Work out the equation for L2. So L2's equation, or the gradient of the L2, is just going to be minus 1 over the gradient of L1, right? Because they're perpendicular. And L1's gradient was 1 over 2. So L2's gradient will be minus 2. So it will be y is minus 2x plus c. Just have to find the c. They've told us it passes through point R, so I can plug R's coordinate into it. So minus 2 is equal to minus 2 times 5 plus c. Minus 2 is minus 10 plus c. So c is going to give you 8. So L2's equation is y is negative 2x plus 8, like so. Right. Write down the coordinates of t. So as you can see from the graph, the t is the point at which it crosses the y-axis. When L2 crosses the y-axis, it's actually the y-intercept, right? So it's just going to be 0, 8, the y-intercept of the L2 equation. D, work out the lengths of RS and TR, leaving your answers in the form k root 5. So we are asked to find the distances between 2 points. So let's find RS first. So you can use the distance equation we looked earlier, right? It's the change in x's over change in y's. So change in x's will be 9 minus 5 squared, plus change in y's will be 0 minus 2 squared. So we'll get, this is 4 squared plus 2 squared, 16 plus 4 is equal to root 20. They asked us to leave it in something root 5, right? So it's just using surds. So I can say it's going to be 2 root 5. Right, the second distance they want is TR. So TR. So R was 5, 2, minus 2. And t was 0, 8. So once again, distance is change in x over change in x squared plus change in y squared, square rooted. So it'll be 5 minus 0 squared plus minus 2 minus 8 squared, which would give me 5 squared plus minus 10 squared, which is root 125, which is 5 root 5. So that's the distance between t and r, and 2 root 5 is the distance between r and s. And then finally in E, they asked us to find the area of RST. So RST is actually going to be a triangle. And for a triangle, it's just height times base divided by 2, right? So that's why they've asked us to find the lengths previously. Because the height will be RT, and the base will be RS, right? So we can say the area is equal to 2 root 5 times by 5 root 5 divided by 2. So we cancel, which will give us 25 root 5 as the area. Okay, so as you can see, we can work out lots of different stuff if we know how to find the distances, and we also know how to find the straight line equations.